Step 4. Creating the 3D script. Go back to the Library Part Editor and click on the 3D script view window to open in a separate window. Type the following lines into the 3D script. Here we start defining the variables we need for the creation of the door frame. You can refer to the 9.2 door variables saved view to see what dimensions these variables refer to. Go to the floor plan and activate the 9.3 glass variables saved view in the Navigator view map. Here you can see the values, parameters, and variables that we'll need to create the door panel with the glass in it. Go back to the Library Part Editor and type the following lines into the 3D script. With this, we are defining the values of the variables needed for the glass. Now we can start creating the door. In the ArchiCAD GDL reference guide, go to page 261 and check the illustration there. What the illustration shows is how you need to create the doors and windows in GDL. The main point is that you need to write your GDL in such a way as if the door or window was placed into a wall that was lying on its side. So what you create in GDL for a door or window will be rotated around its x-axis in ArchiCAD when it is placed into a wall. To put it in another way, what you see as top view of a door or window in the Library Part dialog will become the elevation of the door or window when it is placed into a wall. So keep this in mind when creating them. Type the following lines into the 3D script. Here, we set the pen and material attributes for the door frame. Notice that we are using default parameters coming from the subtype. Type the following lines into the 3D script. This will generate the door frame for us. You can refer to the 9.2 door variables saved view to check the coordinates of each point of the prism underscore. Activate the 3D view window to see the result. Type the following lines into the 3D script. We are setting the pen and material attributes for the door panel. The door has separate default parameters for these, so we are using this to preserve consistency with the other doors. Type the following lines into the 3D script. Here we created the door panel. Let's review it in a bit of detail. You may notice that the first 6 defined points are the same as for the door frame. This is understandable since they must be located at the same points. The 6th point has the status code -1, meaning that a polygon is closed, so any new points will start defining a hole into the body. The next 5 points are the points of the panel around the glass. We used the glass_y and glass_center_y variables defined at the beginning of the script. You may refer to the 9.3 glass variables saved view to check the coordinates of these points of the prism underscore. The status code of the last point of the hole definition is again a -1, meaning that the whole polygon is closed. In such a case, if there are further points defined, it means that there are further holes within the same body. The last 5 points define the hole at the bottom of the door panel we created for ventilation purposes. The coordinates of the point can be checked in the 9.3 glass variables saved view. Activate the 3D view window to see the result. Orbit around it to see the holes in the door panel. We are now ready with both the frame and the panel, but we still need to generate the glass. Type the following lines into the 3D script. We set the pen and material attributes for the glass. We'll use this for the parameters we created in the parameter list. Type the following lines into the 3D script. The adds command moves the local coordinate system along the z-axis so that the glass will be generated in its proper position. The prism_ command generates the glass body. The coordinates of the points are the same as those of the last 5 points of the door panel. The del command undoes the coordinate transformation of the adds command and returns the local coordinate system to its default position. Activate the 3D view window to see the result. If you do not see the glass very well because it is too transparent in OpenGL, you can set the transparency and shading field of the 3D window settings dialog to off. Now, save the door object. Go back to the floor plan and select the door in the wall. In the context menu, select the Show Selection/Marquee in 3D command. As you can see, a rectangular shaped hole is cut for the door into the wall. We need to handle this with scripting. Go back to the library part editor and type the following lines into the 3D script. Here we have a new GDL command. The wall hole command is used to cut a non-rectangular hole into the wall. In cases of rectangular walls, ArchiCAD automatically cuts a rectangle-shaped hole into the wall into which the door or window is placed. The width of that hole is A and its height is B. It is cut symmetrically to the y-axis of the door or window. Cases in which the door frame is non-rectangular, you'll need to use the wall hole command to manually define the shape of the hole that should be cut into the wall for the door or window. This is achieved with the wall hole command. Save the door object and go back to the floor plan. Select the door in the wall and select the Show Selection/Marquee in 3D command in the context menu. You can see now that the correctly shaped hole is cut for the door into the wall.